So this workshop was to be delivered by Francois initially, who is involved with the Data Carpentry project, which I'll mention a little bit more about. My name is Mina Chetinkaya-Rundell. I am with Duke University in our studio, and Colin Rundell is also going to be teaching part of the workshop today. And I'm filling in for Francois as he's currently sadly stuck in the US due to visa issues. But he has prepared majority of the materials here and we've put our finishing touches on it. And I have been involved with developing the reproducibility curriculum for that was then recently adopted by Data Carpentry as well, hence the reason why I stepped in since I'm familiar with the material. So without further ado, let's get started. I have a link to the website for the workshop, which looks like this. And you will see that towards the bottom, there are some R Markdown files that we will work through today, as well as some data files that we'll be pulling in those R Markdown files to create the exercises that we're working with. You don't have to worry about them just yet. As they become relevant, we'll point you towards them. In fact, some of them have more of the solutions as opposed to the exercises, so don't peek ahead. And also, I'm going to guess we all have R installed. But I don't know necessarily that it's a great guess that we all have the most recent version of R installed. Not that you need necessarily the most recent version, but a semi-recent version would be helpful. And we'll be doing the demonstrations using RStudio. Pretty much everything that we're showing today you could do without RStudio, but some of the framework that we'll be discussing in terms of using R Markdown for your analysis, things are a bit easier when you have the push-button access with RStudio, so that's what we're going to be demoing. But if you have your own method of working with those and you prefer to stick with that, that's obviously perfectly fine. And then I also have I'm having a little bit of internet trouble, as is always the case, but all the materials are on this GitHub repository, and I just was having a bit of a difficult time pushing the last version of the slides with the internet. If you would like, you can pull them from there, but otherwise, as soon as I can get push them there, we'll give you the link to the slides at the end as well. All right? Any questions before we get started? Okay. So in terms of the content here, we're going to be starting with the assumption that you use R or want to use R for your analysis, at least majority of the time, perhaps in conjunction with other tools. And we're going to be kind of demoing what an easy onboarding kind of to doing things reproducibly in terms of your analysis in R, both in collaborative settings with other people or just with yourself. But I guess let's start with giving a little bit of a motivation as to why do we care. This is a somewhat recent special issue of Nature, the journal, and they kind of took their stab at parsing through the reproducibility crisis. So they actually went through quite a few important and recent studies, and what they found was that only 6 of 56 landmark oncology papers were confirmed. 43 of 67 drug target validation studies failed to reproduce, and effect size overestimation was common in all of them. There are many, many reasons why this might be the case. What we're going to be talking about today is only part of the story, but it's a part of the story that we as data analysts can kind of help with. There are other reasons of irreproducibility in science. Some of them perhaps happens in the lab settings during the data collection time, which for many of us might be before we even get to interact with any component of this study. But we're going to set those aside for now and kind of work on the bit that we can do our best with. I will say that in my experience of trying to reproduce studies from before, things never go as quickly as planned. If it's my own work and I've been good, I have a better luck, but I can't say 100%. There are a variety of reasons why that might be the case, from sloppy work, but more often that's not necessarily the reason. But things changing, infrastructure changing, the packages changing, your optimization algorithm changing, whatever. So we'll talk a little bit about how to deal with all of that. If you've ever tried to reproduce anybody else's work, especially anyone who you're not working closely with, and tried to email them saying, excuse me, I'm having a really hard time figuring out where these 3 records in your data went. Good luck getting a response to that. I think I've actually personally managed to offend people with my email to the point of no response or saying, I did what I can at the time, the tapes have been destroyed. So we want to avoid these situations, as you can imagine. Why does reproducibility matter? Lack of reproducibility in science causes significant issues. So that could be for science as an enterprise, for other researchers in the community, for public policy. So I'll give an example on this. I don't know if you're familiar with this study. I think it's from now about 2 years ago. There was a paper about gay marriage that was published in Science, and they actually retracted this paper without the lead author's consent, which is something that is a very rare occurrence. The study was on how canvassers can sway people's opinions about gay marriage. So the idea was that, are we all familiar with the term canvassing? So people are going around door to door and kind of trying to convince people of their agenda. And the hypothesis in the paper that was shown to be successful in the paper was that if the person who is canvassing is gay, so they can actually tell a personal story, that they're going to be a lot more likely to convince the people answering the door than otherwise to go out and vote. The original survey data was not made available for independent reproduction of results, and the survey incentives were misrepresented, and sponsorship statements were incorrect. So there were a variety of reasons, but as you can see for that second bullet point, I put part of it in the parentheses. So that aspect perhaps is not the job of the data analyst, but that other bit, making the data independently available, certainly is something that falls on our laps. 2 grad students from Berkeley attempted to replicate this study, and they actually discovered serious issues with the data, and I think what's interesting is that they were able to show that data were almost certainly fabricated, and not only that, but they were able to show how these data were generated using R, actually. So if you want to read a bit more about this, over here I'd strongly recommend it, but this had incredible public health impact, because after this study was published, actually Planned Parenthood spent a bunch of resources and funds to do something similar about abortion, with people canvassing, being able to tell their own stories based on the supposition that this method worked. And we don't know if it works or not, but we certainly know that the results shown in this paper were not reliable. Another one for patients. So here is, if you like to sometimes, if you ever cherish in other people's kind of sadness, go read Retraction Watch sometimes if you're feeling bad. It's like, you can be like, well, I'm not that bad every once in a while. So it's often a good read, and here's one headline from it. Seizure study retracted after authors realized data got terribly mixed. This is a quote from what the author said. So the article had been retracted at the request of the authors. What they found is that the data of 2 hospitals got terribly mixed, whatever that means, and the published results cannot be reproduced in accordance with scientific and clinical correctness. Chances are some labels got mixed up, and this study was recommended for, was used then for making recommendations for medication dosage to patients. So you can imagine now we take a step back and say, well, we've been making these recommendations, but we don't necessarily know that the study results were reliable. So, and additionally, it's important for oneself as a researcher. So if your research is difficult to reproduce, it impedes your future self and your lab, right? Trying to, go through some analysis, a few months later somebody asks you something about it, and you're thinking, all I have to do is just rerun my scripts. And it's quite annoying when you do that, and the results look different and you have no idea why. More reproducible research is faster to report, in particular when the research is dynamic. So think about data tools, using parameters for putting together your analysis. And more reproducible research is also faster to resume or to build on by others. Maybe one thing that is not as fast is if you're thinking, I'm just going to very quickly drag and drop a few variables here and sketch up this graph real quick and send it out. Chances are setting up your whole directory the right way, writing some scripts and whatnot at the very beginning, and documenting your work can take a little bit of time. But trust me, that's going to be investment that is well worth it in the long run. Unfortunately, it tends to be time investment that is not as valued by some of the parameters by which those of us who do research get recognized and evaluated on. But hopefully, as is shown in this little sketch, in the long run it pays off, but in the short run, I think what is useful is tools that make it not a burden on the researcher. So those are the tools that we're going to highlight today. Computational research, when we think about this, your methods are codified by definition, but it can still be pretty challenging to reproduce. Think about the dependency hell. Most software has large and often invisible recursive dependencies. So anyone can fail to install, conflict with those of others, and the exact versions can affect results. Documentation gaps are also quite frustrating. Code can be very difficult to understand if it's not documented, even your own code. Once you sleep overnight, it's like the next morning you're a whole new person. Documentation gaps and errors may be harmless for experts, but they can be often fatal for method novices. So if you've ever worked with people you're mentoring, for example, maybe a student who's just starting in your field, you can't really expect them to necessarily understand your reasoning for some of the decisions you've made in your analysis. So when we think about documentation, I'm not just talking about documenting it so you're explaining what you're doing, but also why you're doing it. Why did you choose that value of a starting parameter? Just a few notes there is going to help you immensely in the future. Also, there's unpredictable evolution. So scientific software evolves constantly and often in drastic, rather incremental ways. And as a result, algorithms and parameters can change in unpredictable ways, and hence your code can fail to render after just a short time. I would wager that quite a few of us have had this experience in the past. If you're interested in kind of walking through a case study, I have a link here in the slides to an experiment. So 3 researchers who they believed that they were indeed doing everything in their power to make their research reproducible. Then what they did is they kind of like swapped papers and tried to reproduce each other's work, and still were having quite a bit of difficulty. And so they wrote up their account here, and it's kind of quite interesting and refreshing to read. Another aspect of this is training. So when, as I said, the steps that you need to take for making your work reproducible can indeed be quite time-consuming. But if you have the right training from the get-go, and you have a way of looking at your projects in a way that you don't have to go back and make it reproducible, you kind of just develop your work as such, that can be a lot more impactful for us to train new researchers to be able to do this. So I was involved with this project of developing a curriculum for a 2-day reproducible science workshop. We had 21 participants, statisticians, biologists, bioinformaticians, open science activists, programmers, graduate students, postdocs, untenured and tenured faculty. So you can see different walks of life, different experience levels who worked on this curriculum, and the outcome is an open source reusable curriculum for a 2-day workshop on reproducibility for computational research. This is the curriculum that Data Carpentry has adopted and have been running sessions, so if you come across one where you live, if you're interested in that, the materials are open source, so if you would like to train yourself or train others that you work with and you'd like to kind of work with those materials, you're also welcome to do so as well. This is the 2-day syllabus for this workshop. We start with a motivation and talk about best practices for organization, for tabular data, and literate programming. And then we also talk a little bit about version control and Git and automation. And finally, sharing, publishing, and archiving your data. This workshop is a condensed version of this, and you can imagine we can only get through a small chunk of this in 3 hours, but we'll give you the highlights, and if you're interested in more, as I said, the materials for the 2-day workshop are available. So we're going to start with an exercise, and it's a 2-part exercise, and I will walk you through the 2 parts so that you can kind of work on it in your own time. The first part is on your own, and the second part is a swapping exercise. We have a small data set here, and I'd like you guys to download the data and use whatever workflow you're comfortable with. So don't think about just think about how would you do this if you were doing it on your own. We have data from Gapminder. Are you guys familiar with what Gapminder is? So basically, it's an online tool for visualizing a lot of country data. A lot of the data comes from resources like the UN and WHO and whatnot. So we have data from many countries, but the task is to visualize life expectancy over time for Canadians in the 1950s and 60s. The data comprised data from a lot more years, using a line plot. And what you'll see is that something should be clearly wrong with the plot you make. Then we would like you guys to go back and fix the issue in the data in whatever way you think is the appropriate or easy way to do it, and then visualize again with your fix. If you're done with this very quickly, and you'd like to try, you can try to add additional lines for 2 other countries, Mexico and the US as well. The second part, once you're done with that, is turn to the person next to you. That's your collaborator. Introduce yourself, say hi, and swap. So one thing I forgot is write instructions of how you did this. And then we would like you guys to swap instructions so that, let's see if they able to reproduce your work. It is possible that you use tools or technology that your collaborator is not familiar with. That's kind of how real life works as well. So think about it as giving a 1-sentence brief explanation, but leave it there. The goal is not for you to walk your collaborator through it, because usually you don't walk your collaborator through things, right? You send your documentation to them and you expect them to reproduce. So the idea will be as if you're not sitting in the same room. Does that make sense? So I'm going to leave things on this slide here, just so you can see the link as well. But if you're done with that, move on to the second slide and swap instructions and discuss. We'll give you guys, we'll do a check-in in about 10 minutes or so, and then see how much more time we need for the discussion. And myself and Colin will walk around if you have any questions, all right? This link was working for you? I wonder if it's just are others having like a slow Wi-Fi issue? And it's a slow Wi-Fi issue, not a dead link issue. I believe. Is anybody able to download the data? Okay, so the link should be working, but we're unfortunately. Okay, so I think we're having a bit of a slow Wi-Fi issue, so hopefully that'll resolve itself quickly.
Everybody tries to access it at the same time, right?
Yes, only this half of the room try first. It's just it's a small CSV file. I shouldn't have started it. Uh, uh, I don't have a USB. You have the file downloaded? Yes, will do. Do you have it down? I think it's just gapminder.csv, right? Oh, yeah. Okay. I think it should be here now. And there is a USB right here if you. I'm trying to see if I can put the link somewhere, but I like the workshop link, but I don't have another screen to add on to this. No, I know somebody was asking. Could I see a show of hands as to I have the data, I'm now working on things? Okay, maybe about half the room. And anybody else? once you're done with this bit, remember, swap with the person next to you, behind you, somebody near you, and try to reproduce their work. Part one, done? Sounds like it. No? Okay.
Trying to get this out.
Oh, what just happened? We'll give you guys 3 minutes to wrap up the discussion. All right, so I think maybe we can come back and kind of discuss how things went. What tools did people use? Let's say maybe R is probably dominant. Are there any other tools than R anybody used to do the exercise? Yeah? You were using Minitab, great. Any others? So, when we do a similar exercise, you can imagine it not an R conference. The answers are quite more varied, and the type of software used varies a lot as well, from point-and-click options to other programming languages. So very similar inner workings as R, but a different syntax. What made it easy or hard for reproducing your partner's work when you guys did the swap? Anything that you guys would say made it easy or hard? Yeah? Different coding styles. So even within the same language, you might have a very different way of solving the problem, and it may not necessarily be as decipherable as you thought it was when you first wrote it up. With Minitab, if you were able to do a swap, did your partner have Minitab installed? No. So that's another thing, right? So when we're dealing with software, especially if it's proprietary software, they may not even be able to get it installed. But even if you're using R, if your collaborator is not using that, that's one additional step they have to take. Variety of levels of experience with the type of analysis you're doing is probably going to be an impediment as well in most collaboration. So think about it this way. In a real life setting, what would happen if your colleague or collaborator is no longer available to walk you through their analysis? So here, you guys are sitting next to each other, and if you have a question, it's easy enough to just turn around and ask. But what if you don't get that response? What if it's that email that you're not getting a response to? Or, to be honest, what if it's your own work and you really have no recollection of how you got there in the first place and you didn't document your work? What would happen if you had to swap out the data set or extend the analysis? So if I now told you guys, you already had a bunch of time to do this, and now I'm going to give you a different data set and you only have 30 seconds to finish that up. For some of your workflows, that might be sufficient. For others, that might not be. In a real life setting, 30 seconds, nobody's going to give a 30-second deadline to you, but if this is an extensive analysis, you might have a day or two, and that may not be sufficient. What if you caught further errors and had to recreate the analysis? You only made one plot. Recreation is easy. What if this was a whole report that you wrote, right, with figures and numbers? What if you had to revert back to the original data set and start over again? What was the obvious issue in the data? What's that? One crazy outlier. Does anyone know the value of that outlier? Yeah? What does 999 mean? It's a missing. I don't know who came up with that. But it's an evil thing to do. And what are some ways of correcting that value? How have you guys chosen to do that correction? Yeah? You can correct it while reading in the data. Oh, and with NA strings, so then you can convert that to NA. Great. Any other ways? Is that the only way we've done the correction? Yeah? We can drop the we can read the file in with that and then drop the observation. Yeah? Compute the mean of the neighboring value, so do some sort of interpolation. So now we're using the data to impute that value. And for any of these things, so these are different ways of handling an outlier or an NA or something. Let's say you computed the mean. How did you actually get that information back in to the data? Do we code that up? Do we go into the data file, overwrite it? That's part of your script. So now that it's part of your script, if you were to give me your script, now I can see how you got to that number, right? Now I'm going to give some of you guys a heart attack, but some people are going to open this file up in Excel, search for 99999, type in their favorite number there, close it out. No record to be found of that. And I think that is quite a common practice, right? It happens. And these are the types of steps in the analysis that really break the reproducibility going forward and make it really, really difficult for anybody with whom this raw data is shared to do that. I'll tell one quick anecdote here. In a past life, I used to be an actuary, actually. But I worked for a company where we did a lot of data analysis. HR data would come to us from our clients. Everything had to be documented, incredibly, because everything could be audited at any point in time. So when there is such a financial and threatening thing of audit looming over you, you document your work. So now, even though nobody audits me, I always think, how did we do things there? How did people do when millions were at stake? And people still do sloppy stuff when millions are at stake. But I think thinking about it in that sense, because we don't necessarily have these auditors in science often. Yes, we have reviewers, but they rarely see our data sets, right? So think about it as, what if somebody was to take a microscope over? How would we do that? So let's talk about 4 facets of reproducibility. Documentation. So that's explanation and commenting of why and how an analysis is carried out in human readable language. So that idea of different coding styles, let's try to take that out of our documentation. Organization is a set of tools to organize your project so that you don't have a single folder with hundreds of files in it. And we'll talk a bit about what are some good practices there in a second. Automation, the power of scripting to create automated and self-documenting data analyses. So what if I did give you a new data set now? How do we do this again? And dissemination is, publishing is not the end of your analysis, right? Getting a paper out. Rather, it's a way station towards your future research and the future research of others. So what are some ways of disseminating your analysis beyond that PDF paper that is published so that others and yourself can continue that work on that? In terms of documentation, I think I'll pass things on to Colin here, and we'll walk you through our kind of our solution to how we approach this problem, and then continue on from there.
So in terms of all these things, we're going to talk about best practices. Something to keep in mind with all of these, a lot of these are suggestions. We're not expecting you all to go home and like implement every single one of these things to the T of how we described it to you. It's more about the process than the destination. These are things where you sort of work for it. There's plenty of things out there about good enough reproducibility. And the more you think about it, the more you put effort into it, it does add up in the long run, and it both pays off for you and other people who are going to use your work. And documentation is going to be one of the really sort of fundamental things that's going to make your work more accessible to other people and also accessible to you in the future. And those are both very sort of laudable things to work towards. So the first thing I want to talk about, and here in terms of documentation, I'm using it in a very general sense. So like the documentation that you may have just written as you were writing up your script. So that could be the form of comments, or if you're using an R Markdown document, sort of the text that was surrounding the code. If you're writing a package, this could be literally the documentation of the functions in your package. It could be the README file in a GitHub repository. It's anything that sort of makes your work more accessible depending on what your work looks like. What you really need to think about, though, is about accessibility. When somebody comes across your work, particularly somebody who's a novice, who doesn't know what it is, wants to figure it out, wants to see if it's useful for them, you really want to make it as frictionless as possible for them to figure out, is this a useful thing? Is this an exciting thing? Is this something that I want to use? This takes lots and lots of forms, but some very sort of simple things that make it accessible are simple plain text files are sort of the lingua franca. Everybody can read them. You can read them in a browser. You can read them on a phone. You can do whatever you want with them. If the user has to download software to read your documentation, a large number of them are just going to say, screw it, it's not worth my time. They're going to move on to the next thing. So things like even simple documents like PDFs and Word, yes, most people can read them, but not everybody. And again, if I have to take that extra step to look at what you're doing, some of the time I'm not going to do that. Again, we don't tend to get paid for the writing or the organization, but these things pay off. A little bit of investment from the beginning, thinking about it, not just sort of doing it as an ad hoc thing at the end. is really, really important. I come from the land of academics. Way too many projects sort of exist to the point of where somebody gets a PhD and then graduates and then they abandon it. And that's usually the documentation that suffers. I am guilty of that. My PhD thesis, nobody else has been able to do anything with it because I didn't write up the documentation. I didn't do what I was supposed to do at the point because I wasn't rewarded for it at that point. And publishing and updating, so whatever you do, if you put it out on a blog post, that increases the accessibility, more people will find it, more people will use it. And there's really nothing worse than finding a solution to a problem you have and then realize it hasn't been updated in 4 or 5 years. So keeping things fresh and current, it's hard. It's an investment in time and energy. It's a big problem in the open source community in general, but making sure that you're sort of staying current, that anything you do still works down the road is also a very, very important kind of thing to do. Or at least be very explicit about what the dependencies and the requirements are. So, something that I think is a stupendously important idea, and it's finally sort of coming into its own, but has been around for about 30 years now, is something called literate programming. And the idea is not new, but the technology and the tools to make it easy and useful are there now. In particular, in RStudio, this is something that is fabulously useful. And so the idea comes from the early 80s from a guy at Stanford named Donald Knuth. He was actually a speaker at useR last year when we were at Stanford. And the basic idea is that you should, when you're writing programs, the text that describes that program and the code that implements that program should be in the same document at the same time. So basically there's text, code that does something, text that describes the next bit of code, back and forth, and the point is to keep those two things strongly linked together. Why do we care about that? So I'll just give you an example of something that we ran into with Duke and how this solves that problem. So our introductory statistics class, there's a computer lab. We want them to use R, so they go into R or RStudio, write their code, generate a graph, and when we first taught these classes, they would then proceed to take that image, save a copy of it, or copy and paste it and drag it into a Word document. And that sort of works, but it's a very fragile process. So if they're doing everything linearly, they do problem 1, then problem 2, then problem 3. Yes, there's a progression and things sort of stay in order. All of that breaks down tragically if they now go back to problem 5. Because maybe the data frame they were using got modified, maybe they made a change, maybe they redefined a variable and didn't notice it, and they try to rerun that code, they're not in the same environment anymore, and everything breaks. And there's no way for us as instructors or them as students to connect what's happening with the plot and what the current environment was. So we can't debug it and tell them, here's the obvious mistake you made, and they can't also debug it for themselves when they're doing that. And it just becomes this spaghetti mess of all sorts of things, and you can't really do anything with it. Versus, say, something like RStudio with R Markdown. Basically what we have here is the code. So here's a bunch of code for manipulating a data frame, and then the ggplot code to generate a nice plot. So in this case, this is that same Gapminder data, including GDP per capita and life expectancy for a number of different countries, where we also include population as the size of the plot. The point is that this has its own environment, so basically we know exactly what happened when it went in, and if they need to go back and fix it, as soon as they fix the code here and rerun it, we get a brand new document that has the new updated plot. All of it is linked together. It makes the learning easy. It also makes the grading and the documenting, or the troubleshooting, a lot easier as well. And we'll go through this in a little bit more detail, but it's one of these things where it makes the documents fundamentally reproducible. You can't not be reproducible because it's all self-contained in that one little place. And again, the idea is not new, but the tools are now to the point where it's really easy to do. You don't have to worry about it. It's not taking on extra effort for you as a user to do things in R Markdown versus copying and pasting into a Word document. It's just as easy to do it both ways. One other kind of thing just to mention is data sanity checks, in particular with regard to what we just saw in the Gapminder data. We purposely did that. We put in this weird number that screws everything up. But a really important thing is not to just run analyses naively. Have sanity checks. Make sure the data makes sense. This is a particularly sort of pernicious problem because the weird thing we put in there was also a number, so it doesn't change the column in any way. But we do know that we're probably not going to see a person who lived more than 150 years, so we probably shouldn't see a country with a life expectancy more than 150 years. So a very easy thing to do is just put in a check to say, does my data still make sense for what I'm trying to look at? Does that column make sense as age? And so in this case, this is just a little bit of code that you could stick in your document that says, if you see something that's out of whack, stop, let me fix it first, and then we'll go. In programming, often these are called sort of like assertions. The idea is basically, I'm going to check to make sure I've made some assumptions about how the data should work or the code should work. Let me check that those assumptions are actually met before I go on and do something with it and get answers that don't make sense. And then there's more formal ways. So there's a bunch of packages in R for sort of formal unit testing. So you can also use those if you prefer them for doing that kind of thing also within a reproducible document. So you don't need to do a whole separate set of tests. You can include them in your reproducible document. So this is using a package called test that, where basically you just say that it's going to run this little bit of code, and then you expect it to be false, that all of your data should be less than, all of your age, life expectancy should be less than 150 years. And if not, give an informative error message. So what I'm going to spend more time with is let's look at a write-up, and a particularly sort of pedantic write-up of that exercise we just had you do. And so in doing that, I'll be able to give you sort of a brief demo of our Markdown, what it looks like as a document, why we might want to use it, and we'll talk about sort of the various solutions and including some of the documentation stuff we sort of talked about so far. So, get our studio to come back. Is this big enough for people in the back to read, or should I make it a little bit larger? Yes, no? Good? Okay, thank you. So, what I'm currently using here is a newer version of RStudio. So if you just go to their website and download anything in the 1.0 version range, you should have similar functionality. So recently they added sort of notebook-like functionality, which I'm not using a notebook. There's other things about those. This is just an RMD document that you would get from doing file, new file, R Markdown. But the point is that you get some functionality there where you can show your work as you go. So I can show you results in line with the code. All that I'm doing is just running those chunks as we go along. Oh, yes, sorry. If we go back to where to get this. If you go back to the main website for the tutorial, the file that I'll be going through here is the 01 motrepsolution.rmd. So if you download that, hopefully the Wi-Fi is a little more stable now, you'll be able to follow along as well. Oops. Okay, so has anybody here not seen an R Markdown document before? Okay, so just to very briefly explain what's happening here is it's a text document. So like I said, accessibility, things that are just plain text are the most accessible. You can open them up in anything. I'm doing this in RStudio, which gives me some nice functionality, but you could open it up in Notepad or text, whatever. Anything can open it, anything can edit it. You can edit it directly on GitHub however you want. The magic sauce here are these little things called code blocks. And so the idea with literate programming is that it allows us to include code along with the textual document. And so here, this is just indicating that I have a block of R code that I would like to run and for something to happen. So here, this is just setting some options for the knitter package, which compiles these documents and gives us a result. So what you can see here, it's also written up in the Markdown language. So that's basically a very simple markup technique for indicating. So here, this is saying this is packages as a header. So it'll be large, bold text when it gets put together. So basically what we've done here is a very, again, pedantic version of it where we're trying to describe every possible thing. Again, your level of documentation should be appropriate for what you're trying to do. So if you're sending it to somebody who's never seen R before, you might have more towards this end of the spectrum. If you're sending it to somebody who does everything in R all the time, you could have a lot less. So here we're even documenting what packages we're using and why, so again, to try to explain every single step of what's happening, what's going on. So we're using things from the tidyverse, Hadley's collection of packages, because they work together nicely. And this is, again, an example of choosing a particular coding style or a particular approach. Some people don't care for that, and so they might use base R for everything. Base plots, base data manipulation, that kind of stuff, totally fine. Here, again, we're making it explicit what decisions we're making and why. So tidyverse, and in particular, the readr package, ggplot2, and dplyr. So readr for reading in the CSV file, ggplot for the visualization, and dplyr for the manipulation of the data frame that we've read in. And then mentioning test that. So here we're using that meta package tidyverse to read all of those in and load them up. And the only package that we're using that's not part of that is test that, so that needs to be loaded explicitly as well. And so I can sort of follow along with these and see what's happening. So I'm basically just hitting Command Enter to run that code in the console. So, whoops. Sorry, the console's over here. So it gets me a simple way of going back and forth between the console to experiment and play around with things and the actual document that contains what I care about, what I want to use. So gap 5060, this is going to read in that data file using read.csv. So I've read it in, and notice that I'm getting both output here in the console, and then in the document itself it's showing what result happened as a thing. So for here that's not terribly useful, but when I'm creating things like plots, I can look at those and experiment with them as I go along. So for our visualization, basically the data set originally contains many countries. We only want to look at Canada for this particular region, or for this particular visualization, so I'm using dplyr to filter out all the other countries, so I'm only selecting Canada. And again here I'm saving that as an intermediate variable because I'm maybe going to want to use it again later, that Canadian subset. So that doesn't print anything out, and then we're using ggplot to say, okay, we want to, on the x-axis the year, on the y-axis life expectancy, and I want to represent those using a line geometry. So if you've never seen ggplot before, it's fairly readable in terms of what's happening, but don't worry too much about the syntax. And so if we run those, this is what we get. And so again, notice I'm getting that visualization in line with my code so I can sort of see what's happened, because that's closer to what the finished document would look like. So this shows the problem we were seeing earlier, where we sort of have everything that's sort of close to 0 and then one giant peak. And again, clearly something is wrong because we can look at sort of the scale and know life expectancy should never be near 10,000 or 100,000. So that lets us say, okay, let's go back to the data. Let's look at, say, that Canadian subset and see, okay, yep, one of the values is 99,999. So again, the basic steps are going through here, and in this case, did I write any documentation? Is there any text? I could, but again, it's fairly self-explanatory, and again, that's one of the nice things of a lot of the tidyverse stuff. It's pretty clear what's happening from the code itself. So it's up to you to decide what the right balance between those two things are. You don't need to be redundant. We don't want to be sort of saying you have to write out in text exactly what your code is doing and vice versa all the time. Oops. Okay, just to move it along quickly, here's an example of that, again, sort of assertion, testing that something's wrong. So in this particular case, yeah, it says error, there's an improbably large life expectancy. Again, if we were looking at other variables, we might include additional tests. Again, the point is not to go crazy and write a test for every single possible thing, but sort of simple things as you catch them, as you think about them, it's not a bad idea. And again, we could also test for life expectancies below 0. That shouldn't happen either. Okay, so this is the last little section I want to look at. So saying, turns out that there's a data in the data file. Life expectancy for Canada in the year 1957 is coded as 99,999. It should actually be 69.97, or 69.96. We now make this correction. So here I'm using dplyr again with the mutate function to change that one particular entry. And again, I'm making it very explicit that I want to change it for Canada and the year 1957. And I'm setting it to this value. Based on what we've told you so far, is there a problem here? It's something I didn't notice before, and it just came to mind recently. In terms of like provenance, documentation, that kind of thing. I'm just telling you that that's the right answer, and I happen to know that because I deleted the right answer to replace it. But in the real world, if you came across something like this, so one of the examples somebody said is, okay, we could plug in a linear interpolate. So basically I take the year before and the year after, and I take the average of those two and plug that in. That's fine, but that would be a very good place to say this is what I'm doing in terms of that process as a way of replacing it. Here, me just saying that this is the right answer that's just an appeal to authority. You don't know if I know that for a fact or not. So if I was pulling it up from, say, like the CIA World Factbook or the WHO or the UN, that would be a very good time to cite, okay, WHO reports the life expectancy for Canada in 1957 to be this, and that's why I'm plugging in the number. So again, all of these things, it's just about being a good citizen, doing good science. Anything like that, you need to justify where did it come from, or at least pass the buck along a little bit to somebody else and say, okay, this is what I think it should be. And here, again, I'm replacing that original GAP 5060 data, which is sort of, that's fine. What we want to say is sort of the cardinal sin is do not touch the raw data. So the raw data is the file that's on the disk. Anything that I'm then modifying from that, I can read it in and do whatever I want with it. And in this case, then I might say rewrite this data out as a modified version of the raw data, so an intermediate thing, and say this is now the definitive version that we should use. And the point is, if I come along and find other errors, I can make those same changes and then rewrite that sort of intermediate file without having to ever touch that original raw data. And in that case, again, it's self-documenting because you can go to the code, you can see what are the modifications and changes, what are the updates, what are the fixes that you see. We then just replot the data with that new revised version and come out with the new data. So again, the point of this is we're working in one document. It has both our code, it has our text. This is a great thing when you're first learning all of this stuff. And the point is that if I want then a finished document, we're using the knitter package to turn that RMD, our markdown file, into a compiled HTML document. So here, the knit button will do that, and loading everything. This is our final result. And the point is that I can then publish this on my website wherever it has all my code. It makes it very reproducible. Other people can go through, follow it step by step. The other great thing is the RMD document is very easy to publish. Put that up on your website as well. Somebody can download that. And again, it's reproducible because they can run it from scratch. They can hit knit, get the same result every single time. And it's then a very good starting place for them if they want to play with the code and say, what if I did Angola instead of Canada? I want to look at that. They can go and modify one line of code and get the result as well. So it's a good way of, again, collaborating, getting people to work with what you've produced. So all of our plots, all of our code, everything else. And there's plenty of other features here so you can turn things on and off if you think it makes, hiding the code makes it more attractive, that kind of thing. You can do very, very fancy stuff with this. And if you work in an organization that insists on things being Word documents, you can compile an R Markdown document to Word. It totally works, it's fine, so there's lots and lots of these options out there. Do we have any questions on, yeah? Yes, so there's a scaling issue here. So basically, when I have an R Markdown document in literate programming, every time I hit knit, it's starting from scratch. That's both the beauty and the curse of it. So the reason that's reproducible is it's working in its own environment. It doesn't care what you've done in the console before or anything else. But what that means is if you have a more complicated thing. So I do lots of stuff with Bayesian models, so you have to run these long computational simulations to get a result. And those take hours or days or months to run. And I'm clearly not going to sit here, hit knit, and wait a month for a result to pop out. There are ways to deal with that. And so what you start to do is start to modularize your code. So you'll have separate scripts that then produce some kind of R data file that you can then have dependencies on. We'll touch on it a little bit today, but I think for true large-scale reproducibility, the tool that you want to depend on a lot is the Unix tool called make. It's a really beautiful thing of saying dependencies. So if I generate a figure, here are the things that needs, and you can sketch them out all in a text file, and only the things that need to be updated get updated. Biostatistician at University of Wisconsin, Carl Broman, has a wonderful document, an article on reproducibility using make for that kind of stuff. So yes, this is a stopgap for early, easy stuff. But as soon as you start to get to those more computationally complicated things, yeah, you start to modularize where you don't have to rerun slow things over and over and over again. And you can do that if you start getting even large GG plots where you're plotting millions of points. In that case, sample or do something else. Any other questions? Yeah. Package versions can be a nightmare. There's a number of solutions out there. PackRat and Mina, what's the RStudio package version control? There's a number of them out there. It's a hard problem. I personally just spent a week revising something because somebody updated a package and changed how a function worked, and suddenly broke a bunch of my code. CRAN is, for like a large-scale package maintenance organization, does a really good job of saying like, okay, you've released a new version of your package and it broke X, Y, and Z, but they can't catch everything. So there are tools out there where you can sort of run a script at the beginning, it'll capture your session and say, here are the exact versions you're using, and then we'll try to sort of recapitulate that when you run stuff. I personally haven't played with them very much. It's a really hard problem, I'll say, but there are people who worked on it and come up with solutions, but I'm not the best to speak to that. Oh, Docker containers are also another option there where you sort of set one compute environment and then let it sit. Again, that's a little bit heavier weight unless you really have sort of serious problems with that. But that, for like Docker containers, so Docker are these lightweight virtual machines that you can run on your system. So you can set up a particular version of Linux with a particular version of software that you can then run, and your code runs within that as opposed to your computing system. Other questions? Okay, we'll continue on. Where was I? So, we're going to try to hit you a little bit more with the carrot and the stick kind of component of these things. So, take the next few minutes. What time is it? Oh, are we at the break? Okay. Sorry, the clock there is off. So we'll take the next 5 minutes. Basically, there is our two other data files. So again, you can get those. I think this is probably the easiest place to find them on the main website. So Gapminder 7080 and Gapminder 90 Plus. And so what we want you to do is basically create the same plot you did before, but now we want you to use the data from these two other files as well. So in that case, you should be able to get a continuous range of dates from the 1950s all the way through the 1990s, 2000s, okay? And what the goal here is to see is that some workflows, basically this means you're going to have to start from scratch, you're going to have to rewrite everything or at least heavily modify the existing code. Other workflows, it's going to be very natural to just sort of integrate this in right away and you'll get the same result. So we want to sort of compare and contrast those. So take the next 5 or 10 minutes, 5 minutes, I'm told, to start playing with that, see sort of how well you're able to do that, how much changes you need to make, and then we'll come back and sort of talk about how well this works within contexts like R Markdown.
Say, how do I get to where you're going?
Let me pull that up.
Yeah. You're from your local hard drive.
Oh.
Not the repo.
Oh, sorry.
So the website is over here. I'll try to put that on top of the slides. And that's where you can download the data files. Is there a way to make this sit on?
Zoom in. Go to the slides.
But you closed the slides, didn't you? All right, I think now I can see. We'll purposely give you guys a short amount of time to see if your workflow works to do it in that time frame or not.
Oh, that's the end of the hour. I know. No, that worked. Yeah. Sorry, yeah. I didn't click on it, I typed it in. It does work. Is that 1B? Okay, so we'll stop you there. Basically, what I want to demonstrate with this is sort of, again, why all of these tools working together is a very, very useful thing. So I'm going to go back to that original solution document that we went through together, and basically I'm just going to edit that. So basically saying, this is my original solution to the smaller problem of just the 50s and 60s data. Now I want to do the larger thing where I'm going to bring these two other new data files in, so the 60s or 70s and 80s and the 90s plus. And basically what I'm going to say is that I literally only have to modify sort of one line of code, and I get everything else more or less for free. Okay? And most of your workflows, if you were doing things in R and scripting them already, is probably similar. But again, what we're going to save on is that extra sort of step down the road of then having to modify and update your documentation as well. So basically what we're going to do here is say, okay, gap 50s and 60s. And in this case, some of the naming I might want to go back and revise later, but what I can just do is this. Say, okay, that's going to read in the first data frame. Now I have two other data frames that I want to read in. I'm going to assume, and this seems a reasonable one, that they're going to have the same columns, so I can just basically stack all of the rows together and get something working. So read CSV 70s and 80s, and read CSV 90s plus. So this is the quick and dirty solution. So hopefully by doing this, this will now just work, and I'll now get a much larger plot of each of these things. I'll get the entire range. Notice I haven't done anything about fixing the error we saw before, everything else. It's going to sort of just come for free, because as long as I have that data frame in the same context with the same columns and the same structure, I'm just looking for the entry for the year 1957 in Canada and fixing that one. So it doesn't matter if there's extra rows that it has to ignore or not. So knit it, and wah-wah, something is complaining. Sorry, I screwed up. Oh. Sorry, my foray into Word broke my document. So let's see. There we go. So now I'm getting that plot is updated automatically with the results of those two extra data frames that I didn't have before, both here and then in the 3-country plot and everything in between. I could leave it there. That's probably not a good idea. So in this case, having done things like name my original data frame gap underscore 5060, that's not true anymore. And so if I didn't do that and I passed it off to somebody else, they're probably going to be confused. Was this just a mistake, or did you intentionally mean that, and now is the mistake the name, or is the mistake the data? That's not clear. They'd have to make a decision. So I probably should go back in and update things, so rename it. So these are now just called gap instead, something like that, and generally sort of clean it up to make sure it makes sense. But the point is that this is a very, very quick and easy update. And so that's the kind of thing why this is a very useful tool for teaching as well. In a computing lab, student realizes they made a mistake, they can go back, make one change, update it, they have their full document. They don't have to go back and figure out, okay, here's one of the plots, let me make sure I rerun that and copy and paste that into the Word document and update my text, so on and so forth as you go. So we have a full cleaned up version called 2 extended solution, so you can look at that for a little bit more refined, clean version of it, but the idea is basically the same. We're just going to read the 3 of them in, combine them together, and then everything downstream will then update automatically when we compile the document. So in the few minutes we have before the end, go back to presentation, I'm going to let Mina do 1/3 demo on some of the little bit more of the functionality and the literate programming aspects of our Markdown beyond.
All right, so this time, instead of having you guys work through the exercise first, I do have a demo file, and then I think it's going to be time for a break, but I'll leave the exercise up there if people want to work on them after. So on the website, if you grab the 3rd file, More Literate Programming, I wanted to walk you through kind of what is happening here. And really, if you scroll to the bottom of that document, there's a list of kind of the takeaway lessons. So the first thing that I wanted to highlight is creating our Markdown documents that are parameterized, so that you can actually change that parameter and rerun the document And you get to change that parameter just in one place as opposed to, say, everywhere else it shows up in your code. And the way that we can do that is by adding a new argument to the YAML on the top of your document. So we're actually here stating that one of the countries we want to make a plot for is Belgium. And as you can see, in the parameters in the YAML, I actually can include our code as well. And the way I'm doing that is with an exclamation point to indicate some R code is forthcoming, and then the code itself. Now, obviously trying to write a very extended chunk there would be difficult. I think it would make it difficult to parse. But for something simple like this, what it does actually is, now I don't know why you might want to do this, but what it does is it will sample each time you knit the document one of the 3 countries and make the plot for that, okay? It's the code itself is gimmicky because chances are you don't randomly sample countries for which you're making a report, but the idea is that you can actually include R code in your parameters in the YAML as well. And another takeaway lesson here is functionalizing. So we had demonstrated to you in the earlier exercise a ggplot code to make the plot, right? So we pre-process the data and then we plop it into a code. Now one thing you might want to do is say, I'll write a function that makes a plot for any given country, and then at any point I call the function the data set that the data come from, and then the selected countries that I have. So here you can see that I am using the params argument from the YAML, saying grab the first one, that was Belgium, and the second one, which is going to be a random sample from US, Canada, and Mexico, and then a third one that I am defining in my code, just chose South Africa. So if I actually knit this document, even with files I've tested many times, if I'm doing a live demo, trust me, I'm secretly holding my fingers like this to make sure it works. Okay, so what we've done here is we've created the plot country function that we defined up top is basically saying make a plot for me of life expectancy versus year. We're doing some coloring by country and also sizing the points by GDP per capita. And if I actually run this again, this particular country, the United States, might change. I'm only saying might because we're sampling 1/3, so I don't know if it would or not. But the idea is that you can include that code there. So here is one way of parameterizing your our Markdown document. I think this is an especially useful feature if you do analysis where you tend to do your analysis on subsets a lot. So countries actually is something that does make sense. We tend to do analyses for certain time periods, or if you have data from a variety of, I don't know, genes and you only want to process it or do the analysis for a few of them versus the others, this can be very helpful. The idea of using these functions to generate the plots, it makes it easy to do things like check the type of the variable you're feeding into it, so you can include tests in there as well within that function, the test that we had shown earlier. And also just in general, reducing code repetition. I think the rule generally is if you are copying and pasting your code for the 3rd time, maybe you want to start functionalizing like at 2, you can probably still get away with it. One of the questions that was posed earlier was about what if I have a really extensive analysis? As this R Markdown document grows, it becomes a bit harder to actually parse through that. Well, one of the reasons that it grows is the extent of your analysis, but another one is the number of lines of code you have. And sometimes it might be possible to reduce that by functionalizing things. The last thing that I'll mention is more on the visual end of things. So this is not necessarily a reproducibility thing per se, but one of the criticisms you might think of using this paradigm of generating reports with our Markdown is, well, if everything just looks like our output looks like in the console, it's not always the most visually appealing thing to look at. I think perhaps we have eyes that are trained for being okay with the the non-formatted R output, but a lot of people you might be working with, or perhaps clients, you may not, that doesn't look as polished. With a single line of code, it's possible to kind of take your table from what it would look like in the console to look something a little bit more visually appealing like this. And here I'm happen to be using the cable function from the knitter package to do that. There are a variety of ways that you can do kind of prettify your output with minimal code. And if you are wanting to do your work reproducibly, but then also share the output with people who aren't familiar with R or don't want to see the back end, but just the results, all we can do is hide the code here. So I think if I was to do echo false and rename my document, instead of kind of hiding everything, I'll just show. And this is the bit of my report that say I'm sharing with the client. Everything is still reproducible. All my work is still there. They don't have to see it though. Okay? Any questions about the parameterized R Markdown functionality? Yeah. No, not necessarily, at least not in this format in terms of if you're looking at a static output. There may be other reasons why you might want to use this. So for example, if you were feeding this into some sort of a Shiny app, for example, and you would want people to be able to kind of select the variables by drop button. That's getting a little bit closer to that. I think there is a RStudio product, RStudio Connect, that allows your users to actually do select parameters from a drop-down menu. So they're kind of running R behind the scenes without realizing that at all. So if you live in those domains, that might be helpful. Otherwise, I would say the one reason I can think of, it's not a code efficiency thing or anything, or a computational efficiency thing, but if this is like this choice is the bulk of your analysis, maybe just setting them up top makes it easy to identify. Any other questions? Yeah, in the back. So there, that's perfectly fine as well. And what you could do is remember that the R Markdown file looks at the directory that it's in or any subdirectories of that. Or actually, you can climb up as well. But in general, I think it makes sense to have your R Markdown file live in the root of your project directory. So perhaps you have another R directory in there with R scripts that have functions in them that you then source into your document. And that's perfectly fine as well. In fact, it might be a preferable thing to do, especially if those functions are shared by multiple projects and you want to make sure that you're maintaining the same code and not copying them between projects. Yeah. So, for example, in this particular case, we are calling a ggplot within a function. So I think that would be one way of doing that. I do know that some things that... Oh, sorry, repeat the question. I'm sorry. I'm really bad at that. I think the question was... Oh, that monkey. The question was best practices for putting ggplots or calling ggplots from other functions. So this would be one way of doing that. I'm not necessarily saying the type of code here is some sort of best practice, but it's certainly doable. And especially, I think, if you have things that you tend to pass a lot to them. But one thing I would say is I've seen this kind of work, for example, where people will put it in a function and the idea is that you style them similarly. At that point, might it be worthwhile to invest in creating your own like theme for the ggplot, right? If that's something you do regularly, I think that investment might be worth it. So instead of plopping it into a function, just adding it as a layer. So it all depends on what it is that you're trying to keep consistent between the plots. All right, I think it is time for a break. What I am going to do is I'm going to leave these up here. At a minimum, try the first exercise at some point, because all it is typing in a few letters and knitting. So you can say, I have knit my first R Markdown document if you have not yet done so. And if you'd like to work on the rest of it, that's perfectly fine. We'll be back at 11:30. Thank you.